Hello friends, now we discuss some example based on radial velocity, transverse velocity, radial acceleration and transverse acceleration. So this is the given. The path of a particle is equiangular spiral if the radial velocity and transverse velocity are constant. So here it is given that radial velocity and transverse velocity both are constant, and we have to prove that the path of the particle is equiangular spiral. So first we write here what is given. So given is here radial velocity. Radial velocity, we know that radial velocity is dr upon dt. This is equal to constant. We suppose that this is equal to mu lambda. So first we suppose that here it is given that radial velocity and transverse velocity both are constant. So radial velocity is dr upon dt and dr upon dt is given constant. We suppose that this constant is equal to lambda. Now it is also given that transverse velocity, this is r d theta upon dt, this is also constant, and suppose that this is equal to mu. So this is first equation and this is the second equation. It is given. Here given is radial velocity is constant. We know that the radial velocity is dr by dt, and we suppose that this constant is equal to lambda. Again it is given that transverse velocity is constant, and we know that transverse velocity is r d theta by dt, and we suppose that this constant is equal to mu. Now we have to prove that the path of the particle is an equiangular spiral. So first we divide one equation by second. So we get here dr by dt divided by r d theta by dt. This is equal to lambda divided by mu. You can see here equation first divided by equation 2. So this dt is cancelled out. So this can be written as dr upon r d theta is equal to lambda upon mu. Now we using here variable separable. So this can be written as dr upon r is equal to lambda upon mu d theta. We can see that this is the first degree differential equation. Here we use variable separable method. So the term of r with dr and term of this is d theta. Now we integrate both the sides. Integrate both sides. We get here dr divided by r integration of lambda by mu d theta. Here we can see that integration of 1 upon r with respect to r, this is log r, and lambda upon mu, this is constant. Integration of theta, this d theta, this is theta, and we take here some constant log c. Log c is the integration constant. Now we can see this log c, log r minus log c, this is equal to lambda upon mu theta. We transform this log c in the left hand side, so we get log r minus log c is equal to lambda upon mu theta. Now we can see here using property of log, so this can be written as log r divided by c is equal to lambda upon mu theta. So again using property of log, we can write r upon c is equal to e to the power lambda theta upon mu. So this can be also written as r is equal to c times e to the power lambda by mu times theta. We know that this equation is equation of equiangular spiral. So we can see that if the radial velocity and transverse velocity both are constant, particle moves on a path that is equiangular spiral. Thank you.